Welcome to CyberXplain channel. Today we are going to discuss securing AI, your crash course in MLOps security vertical bar CyberXplain. Hey there, welcome to CyberXplain. You've probably noticed that artificial intelligence, or AI, is popping up everywhere these days, right? From your phone's smart assistant to personalized recommendations on streaming services, AI is transforming how we live and work. It's like having a super smart friend always ready to help. But with great power comes great responsibility, especially when it comes to technology. We rely on AI for so much now, and that reliance brings a whole new set of security questions. Think about it, AI can diagnose diseases, predict financial markets, or even drive cars. That's incredible. But what happens if that AI gets confused, or worse, if someone intentionally messes with it? Just like a powerful car needs strong brakes and a secure steering system, our AI systems need robust security. If a self-driving car's AI is strict, or a financial AI gives bad advice, the consequences could be huge. We are not just protecting data, we are protecting decisions and real-world outcomes. So, who's in charge of making sure AI is safe? Is it just the data scientists who build the models, or the engineers who deploy them? Actually, it's everyone involved in the AI's journey, from concept to deployment and beyond. We all play a part, because securing AI isn't a one-time thing, it's an ongoing process. Just like securing a house isn't just about locking the front door once, it's about checking all the windows, having an alarm, and keeping an eye out. It's a team effort, and we are all on that team. Let's talk about MLOps. Sounds fancy, right? It just stands for Machine Learning Operations. Think of it like an assembly line for AI. It's a set of practices that helps teams build, deploy, and manage machine learning models reliably and efficiently. From getting the raw data to putting the final AI model into action, MLOps provides a structured way to handle all the moving parts. It ensures that your AI projects run smoothly, predictably, and can be updated over time. Now, let's bring in DevSecOps. You might have heard of DevOps, which combines development and operations to make software faster. DevSecOps just adds security right into the mix from the very beginning. Instead of thinking about security as an afterthought, like a fence you build after your house is finished, DevSecOps bakes security into every single step. It means testing for vulnerabilities early, automating security checks, and making security everyone's job, not just a separate team's. So, what happens when we combine MLOps and DevSecOps? We get DevSecOps for AI, or as some call it, securing the AI development lifecycle. This means we are applying those security-first principles to every stage of our AI assembly line. From the moment we collect data to the second our AI model is live, we are thinking about potential risks and how to protect against them. It's about building AI that's not just smart, but also resilient and trustworthy right from the start. Why go through all this trouble? Well, an unsecured AI can lead to massive problems, from privacy breaches to financial losses, or even safety hazards. Imagine an AI system that accidentally leaks sensitive customer data, like what happened to a major social media company due to an API vulnerability. Applying DevSecOps principles to AI helps us catch these potential blunders early, before they become front-page news. It's about protecting your organization's reputation and its users. Let's dive into data security. Think of data as the food for your AI. Just like you wouldn't eat spoiled food, you definitely don't want your AI model training on bad or insecure data. The quality and security of the data directly impact the AI's performance and trustworthiness. If the data is tampered with, incomplete, or contains sensitive information that shouldn't be there, your AI model will learn all the wrong things and potentially expose secrets. It's the foundation of everything. The data that feeds your AI takes quite a journey. It starts with collection, maybe from databases or sensors, then it moves to storage, perhaps a cloud data lake. After that, it's processed and cleaned, then used to train the model, and finally, sometimes even used for ongoing monitoring. At each of these stops along the journey, collection, storage, processing, training, there are potential weak points where security can fail. It's like a long pipeline, and every joint needs to be solid. Let's imagine a real-world scenario. You work at a big financial institution, and your team is building an AI model to detect fraudulent transactions. This AI will be making critical decisions about people's money, so trust is paramount. The data used to train this model comes from various sources, internal transaction databases, customer interaction logs, and even some third-party financial risk feeds. How can we be absolutely sure this data is accurate and hasn't been tampered with before our AI even sees it? For our financial fraud detection AI, we need to apply robust data validation. This means, first, checking the provenance of the data. Where did it truly come from? Is it from a trusted source? Second, we use data integrity checks like checksums or hashes. These are like unique digital fingerprints that can tell us if even a single bit of data has changed. If the fingerprint doesn't match what we expect, we know something is wrong. We might also audit access logs to see who touched the data before it reached us. It's all about building a chain of trust. Beyond just integrity, data privacy is crucial, especially with sensitive financial information. We often need to use techniques to protect personal data while still making it useful for AI training. This is where anonymization and masking come in. Anonymization might involve removing direct identifiers like names or account numbers. Masking could mean replacing parts of data, like showing only the last 4 digits of a credit card number. The goal is to reduce the risk of identifying individuals while maintaining the data's utility for the AI. This is vital for compliance with privacy regulations. Even with anonymization, we still need strict access control. Not everyone on the AI team needs to see all the data. Think of it like a vault with different levels of keys. Only specific people, with a genuine need, should have access to certain datasets. This is where identity and access management (IAM) systems come in handy for cloud data stores like AWS S3 buckets or Azure Data Lake. You define policies that specify exactly who can read, write, or delete data. This principle of least privilege is a cornerstone of data security. Finally, we absolutely must encrypt our data, both when it's sitting still, at rest, and when it's moving around, in transit. Encryption is like scrambling your data with a secret code, so if someone unauthorized gets their hands on it, all they see is gibberish. Most cloud providers offer easy ways to encrypt data at rest in storage services and encrypt data in transit between services. This is a fundamental security practice that adds a strong layer of protection, even if other controls somehow fail. Always encrypt, always. Alright, let's shift gears to securing the AI model itself. After all that data processing, our AI model is the brain of our operation. Think of it as a highly complex recipe or a finely tuned instrument that's learned patterns from all that training data. It's the unique artifact that can now perform tasks, like detecting fraud in our financial scenario. This trained model, often a collection of numbers and algorithms, represents a huge investment and contains the distilled intelligence from all our data. Why do we need to secure this brain? Well, first, it's intellectual property. Building a good AI model takes time, effort, and expensive resources. Second, a compromised model can lead to incorrect or malicious decisions. Imagine if someone subtly altered our fraud detection model to ignore certain types of fraudulent transactions. That would be disastrous. We need to protect its integrity and ensure it behaves exactly as intended, even when faced with tricky inputs. This is where AI security gets really interesting. One sneaky attack is model poisoning. This happens during the training phase. Attackers inject carefully crafted, malicious data into your training dataset, which then poisons the model's learning process. For our financial fraud model, a clever attacker could inject fake transaction data that teaches the AI to classify their specific type of fraud as legitimate. The model might seem fine, but it has a hidden vulnerability, waiting to be exploited later. It's like putting a tiny, invisible ingredient into a recipe that only ruins the cake for certain occasion. Another type of attack is model extraction. Here, an attacker tries to steal your AI model itself. They don't need to break into your servers, they just interact with your deployed model, repeatedly asking it questions and observing its answers. By carefully analyzing the model's responses, they can often reverse engineer and reconstruct a copy of your model, or a very similar one. This steals your intellectual property and could allow them to discover weaknesses or build competing products. It's like figuring out a secret recipe by just tasting the finished dish many times. To combat these threats, we need model integrity checks. This means, just like with data, we assign unique digital fingerprints, hashes or cryptographic signatures to our trained models. Before a model is deployed or used, we verify its signature to ensure it hasn't been tampered with since it was approved. We also use version control, like Git, for models, just like we do for code. This allows us to track every change and revert to a trusted version if something goes wrong. It's about maintaining a pristine record of our AI's brain. When it's time to put your model into action, how do you deploy it securely? Instead of just throwing it onto any server, we use secure deployment practices. This often involves packaging the model into secure containers, like Docker images, which run in isolated environments. We also expose the model through secure APIs, application programming interfaces, ensuring only authorized applications can send it data and receive predictions. Imagine a strict bouncer at a club, only letting in those with the right credentials. This minimizes direct access and potential attack surface. Even the best data and models need a secure home to run in. This home is your infrastructure, whether it's on your own servers or in the cloud, like AWS, Azure, or Google Cloud. Securing this infrastructure is paramount for AI workloads. Think of it like building a fortress for your AI. It needs strong walls, guarded gates, and vigilant watchmen. Without a secure foundation, all our efforts to protect data and models could be undermined by weaknesses in the underlying systems where they operate. Who can access your AI training servers, or the cloud resources where your models live? Just like with data, identity and access management, IAM is critical here. Tools like AWS IAM, Azure Active Directory, now Microsoft Entra ID, or Google Cloud IAM let you define precisely who, which user or service, can do what, run a job, access a GPU, deploy a model. You grant the minimum necessary permissions for each role. This ensures that only authorized personnel or automated systems can interact with sensitive AI resources. Your AI infrastructure also needs strong network security. This means segmenting your networks, putting firewalls in place, and controlling inbound and outbound traffic. For example, your AI training environment shouldn't be directly accessible from the public internet. You'd use virtual private clouds, VPCs, in the cloud to create isolated networks and use security groups or network access control lists to restrict traffic. It's like building multiple layers of fences around your most valuable assets, allowing only expected and authorized communication. Many AI workloads run in containers, managed by orchestration platforms like Kubernetes. Securing these is vital. You need to ensure that your container images are built from trusted sources and scanned for vulnerabilities. Running containers with the least privilege is also key, so they can only do what's absolutely necessary. Kubernetes, while powerful, also needs to be configured securely, with proper access controls and network policies to prevent containers from talking to each other inappropriately. It's about keeping each AI pod safe and isolated. Finally, even with all these protections, you need to keep a watchful eye. This means robust monitoring and logging. Collect logs from all your AI services, infrastructure, and application layers. Look for unusual activity, sudden spikes in API calls, unauthorized access attempts, or strange model behavior. Centralize these logs in a system like a Security Information and Event Management (SIEM) tool. Monitoring helps you detect if something has gone wrong, so you can respond quickly, like a security guard watching surveillance cameras around the clock. We've covered a lot, but how do you know if your AI security measures actually work? You test them. Traditional security testing, like looking for bugs in code, is still important. But for AI, we need special tests because AI behaves differently. It's not just about if the code runs correctly, but if the logic of the AI can be tricked or misused. We need to actively challenge the AI to see how robust its security truly is, pushing its boundaries in ways a normal user wouldn't. One key type of AI security testing is adversarial testing. This is where you intentionally create tricky, slightly altered inputs that are designed to fool your AI. Remember our fraud detection model? An adversarial test might involve creating a transaction that looks completely normal to a human eye but causes the AI to misclassify it as legitimate. It's like finding the exact optical illusion that confuses a visual AI. These tests help reveal vulnerabilities that traditional quality assurance might miss. Beyond adversarial attacks, we also do robustness testing. This checks how well your AI model performs when it encounters unexpected but non-malicious inputs. What if the data it sees in the real world is slightly different from its training data, perhaps due to a sensor malfunction or a new trend? Does it gracefully degrade, or does it completely break down and start making nonsensical predictions? Robustness testing ensures your AI can handle the messy, unpredictable nature of the real world without catastrophic failure. It's about building a stable and reliable AI. Wow, we've covered a lot today. From understanding what MLOps and DevSecOps mean for AI, to securing your data, protecting your models, and building strong infrastructure, and finally, testing your AI's resilience. It might seem like a lot, but remember, every step you take to secure AI makes it more trustworthy and effective. Your role in asking questions, understanding risks, and applying best practices is incredibly important. You are not just building smart systems, you are building secure smart systems. Keep learning, keep questioning, and together, we can build a safer AI future. Thanks for watching. Subscribe to the CyberXplain channel. See you on the next video.